My name is Yolanda. I'll be presenting a master's thesis on interpretable machine learning and natural language processing for misinformation data. The big picture is that models are becoming more complex. We need to build trust and transparency between the end user and the model, and legislation such as the GDPR law require the right to explanation. There are three main techniques which can be used to explain model. Firstly, model-agnostic techniques, which can be applied to any model. Model-specific, which can be applied to only a specific family of models. And lastly, example-based techniques, which extract examples from the dataset to try and achieve human interpretability. Our main goal is to leverage off human interpretable technique for misinformation such that we can effectively identify and characterize misinformation. One, understand what behavioral factors can distinguish a misinformation class, and is there contrast in these behavioral factors when looking at datasets from different countries. We use three datasets: an ACID dataset as our baseline data, a COVID dataset which contains news articles related to COVID news from India, USA, and Europe, and lastly the South African dataset obtained from Zenenda Data Repository, which has disinformation data from South African news outlets. The methodology which was applied is we applied 4 example-based techniques to our data set. We extracted prototypes and examined the prototype set to determine the quality of the prototype set. The prototype set with the highest quality will be used for further processing, where we extract key features by using EDA and train an LTSM model on prototypes to probe for linguistic properties between the classes. Psychology study states humans understand or create reasoning through creating a mental model by using examples. There are 4 example-based techniques that we used of clustering, set cover, influential instances, and MMD-critic. To determine the quality of the prototypes, we trained an LTSM model on unseen data not part of the prototype sets. The accuracy score of how well the model predicted helps us to get a sense of the quality of the prototypes selected. The influential instances and MMD-critic were the ones that had the highest quality across the 3 datasets, as their accuracy was the highest. We then used the influential instances as well as the MMD-critic prototype set to extract key features through sentiment and opinion detection, word analysis, linguistic properties, and we further used those prototype set with a model-agnostic technique, SP-align, to determine if we can not extract further information from the prototype set. Our findings and conclusions were as follows. Fake news is shorter in length and contains more capital words. Fake news is more subjective and often opinionated. Fake news uses more adjective verbs in third person and pronouns. Fake news phrases are more aggressive and always around controversial topics. South African fake data has more foreign words as more colloquial words are used, and further, South African text is either positive or negative and hardly any neutral text. We further detected some harmful instances in fake news are very difficult to detect by a lay person. Probing further into linguistic properties and also having a linguistic expert would help in terms of determining the different classes.